Hey everyone, in this video I'm going to create a heart shape I found on random internet website. So I think this is going to be really interesting because I never imagine myself creating this kind of stuff in my life. So let's get into it. So first thing first, we are going to go to Blender shader editor workspace here, and this is a reference image I'm going to use. So if you are like a first time using MathNode, MathNode is basically you can simply think just allow you to give more flexibility on your workflow, to accelerate your workflow you can use MathNode. But in this case I'm going to use MathNode to create this specific case of graph in shader editor. So yeah. By the way, I'm using Blender 2.93 version. It doesn't have to be like a Blender 2.9 version. It works in any Blender version, like a Blender 5.0 for now. So yeah, fundamental mechanism never change. So okay, so I will just go. First of all, we are going to use texture coordinate, and I think this one is the most easiest math equation, and these three are most hardest thing. So we are going to go step by step, so don't take it serious, and we are going to switch it to material view to see how it goes in real time. So to know the x, or where's the x and y, we need to use separate xyz node and connect directly to object to vector. Object is just 3D, which is xyz, and UV is only contains x and y because it is 2D. So we are going to use object coordinate, and to make this thing here x square, we are going to use math node, set it to power, and this x is the base and this 2 square is the exponent. So we are going to connect this thing here, and exponent is going to be 2, and directly connect to the surface, and we'll get this kind of interesting looking graph here. So by the way, x squared is same as multiply x by itself, because the result is same, because x squared equal x times x. So that's why we get the same result. But I'm going to use just a power node because I want to be simple. We are going to keep organizing it. This is x squared plus y squared. Here's a y squared. And we are going to, using math and node, we need to add them each other's x squared and y squared. X and y here, and we'll get this circle thing. It's pretty cool. And we need to subtract with 1. So we are going to use value node, set it to 1, subtract with 1 here, and we'll get this bigger circle thing. And once this part is done, we need to cube them. So we're going to make another power node and set the exponent to 3, and we make this part. It's very simple, right? Okay, and we are going to make this part too. So this part is going to be another power node here, copy this, and this one is x squared, and this one is exponent is going to be 3 because it's 3, and we are going to multiply that each other's, and we are pretty done. And we are going to subtract them using math subtract node. Alright, we got a very interesting hard to looking shape now. And once you're done, we are going to make this more like visible. So we are going to use a vector math node, set it to scale, so that we can see how it goes. So scale node, and let's scale up, and we'll see this hot shape right now, but it doesn't look clean, right? Because of the from the center is like getting brighter and brighter, and it's like this is 1 and this 0, and this is like a between 0 and 1, so that's why it is like kind of gradient thing is happening now. So because which is kind of annoying, so we are going to use math greater than or less than, and we'll get this kind of weird looking. That's why we are going to set it to 0, and we made this hot shape, which is very looking cool, right? We made exactly same result as this reference image, right? Okay, so we made first hot shape. Congratulations. Ctrl J. If you're using latest version of Blender, you need to press F to make a frame, or if you're using like a previous version of Blender like me, then you can use Ctrl J to make a frame, or you can just simply search up frame here and you can make a frame. Okay, it was a very convenient shortcut. So let's just say first hot. Okay, it's very simple, nothing is complicated yet, but it is going to be getting hot and hot as we go up and up. We're going to change the color to the like a little bit slight reddish color, because why not? Okay, second, we are going to make this ugly looking hot. It doesn't look like hot for me, but yeah, whatever, let's go. So we're going to make, as always, we are going to make texture coordinate, separate x, y, z, connect to object vector, and we are going to make, we need to use y and subtract with these formula here, and square root then and plus x square, and is equal to 36. Don't take it too serious, we are going to do step by step. So we are going to make math subtract and connect this thing here. Okay, we need to set it to subtract, and Ctrl H to hide the rest of them, not Y. Okay, so what we subtract that, we are going to make this part here. So we're going to separate x, y, z node again, because we need to use x, this one here, x, and this is absolute. So we have in math node, we have absolute node here, absolute, and yeah, we made it. This is x absolute here, and we are going to make another math node because we can be confused, so please understand. X power, set it to 2. We can be confused, so we are going to organize it. Ctrl J, absolute x here, and this one is make a frame, rename x square. We are going to add them each other, so using math node, we're going to add them here, and yeah, we just made these thing here, and subtract with 6, oh yeah, we made these big part here, and we are going to multiply with 2. And we just made these part here. Wow, it's pretty fast, right? Okay, and this part is much more easier. It's just change a little bit of variable, but we can just copy and paste and change the value. X square, and this one is plus 2, so we are going to change it to math add plus 2 and multiply with 3. And using math divide node, we can make them in a fraction. Okay, math divide, this one is first second, and this part is going to be second second. We made it. We made this fraction here, and we are going to subtract with y here. So we are going to subtract this with y. So we are just going to subtract them. And let's see how it goes. Oh, we got this interesting looking shape now. And once we subtract that, we need to square that. So using math power node, set it to 2, and we'll get this, what I don't know what's going on. We'll get this kind of interesting looking shape. So we're going to make another separate XYZ math power. Oh, we made this x square now, and we are going to add them here. So we're going to math add node, and we just made this weird looking thing here, and we can use equal is math greater than, not greater than, compare with 36, and let's see how it goes. Vector math node, set it to scale. Oh yeah, look at this, we got this hot very good looking go. Oh, we can use greater than node instead. Oh yeah, we got this exactly same result as this one. So this is going to be the second hot. Beautiful, right? Second hot. And we're going to change the color of this frame as always, like a pinkish pink. Yeah. Oh, this one looks very easy, right? This one looks kind of looking tricky, but it's going to be easy. Square root of absolute x. Not that hard. We can do it. So first things first, we are going to make this 5y here. So in a value, we're going to set it to value 5. Texture coordinate, separate xyz, and as you can guess, we are going to multiply this 5 and y. So math multiply 5 and y. So we just multiply that, and we're going to make another value node, set it to 4, and we need to make them in fraction. So we are going to use math divide and connect this 4 to the second socket of a divide, and this one is going to be the first socket. And we just made this 5y over 4. So we are going to keep organizing it. Okay, and we are going to subtract with this absolute x of square root of absolute x. So we're going to make separate x with z, and this x is going to be absolute here, absolute, and we are going to add square root, and we just made it. We just made this absolute x of square root here. Ctrl J, and we are going to name this square root of absolute x. Okay, we're going to subtract that using math subtract node. Connect this. We'll see. Oh, look at this very interesting looking graph here. Because of we use absolute node, we got this like a metered thing, like I'm not whether you guys know or not, because y equal x graph is basically when we put like a positive number here, negative number here, like a -1 or 2, then it will it will make this thing to a positive number. So that's why we get this, like we will get this kind of looking graph here. So that's why this effect exactly works same as the math now. So I hope it makes you convinced now. Anyway, let's keep going. Subtract that, and math node, set it to power, and we're going to set the exponent to 2. We are going to lastly we are going to add x squared, separate xyz, and x square math power, set the exponent to 2, and that is equal to 1. So math greater than, oh wait, we need to add them, never mind. X square, add them, and which is greater than that 1. So we got this really, we got this hot looking, hot, right? We are almost done. X greater than 1, and we'll get this hot shape here. Using vector math node, we can change the whole, change the whole vector scale. So this vector math node is really useful. It's looking like this. I love this. Alright, so we just made this third hot as well. Beautiful. Oh, by the way, if you want to make this on a center, like this, like a slightly on the y-axis now, so to make this a little bit, make it down, we can use vector math node, add or subtract, and we can change the y, x, or z is not going to be working because this is a 2D plane. So y, we can change it to make it a little bit slightly on the center, and to make it looking like a visually more appealing. Okay, I love this. So we made this third hot shape tool. So Ctrl J, and oh, for some reason it okay. We need to make this Ctrl J, rename third hot. Okay, it's pretty cool. Change the color too. A little bit this time. We're going to make it a little bit greenish, like green tea. Okay. Oh, this one looks really hot, but don't worry, it's not that hot once you understand how it works. So basically, we are going to make this thing first, and yeah, let's go. So texture coordinate, separate xyz and x over 5. So math divide x over 5, and once we're done, we are going to make them in absolute. So copy this, and we're going to make them in absolute here, and let's see how it goes. And we'll get this thing gradient looking, this thing here, and we're going to subtract with 1. So switch it to subtract and change the value to 1, and we'll get this completely black one. I don't know why it makes this completely black, but let's keep going. So math power, set the exponent to 2, and we're going to make this one. This is power exponent. Okay, and we are going to subtract with 1 here. 1 subtract. Oh, we get this. We made it back. Okay, and we are going to make square root node again. Square, because this thing here, this is square root that, and we'll get this thin something. Pretty good. And once we are done this thing here, we are going to let's erase it a little bit. Okay, so we made this thing, and subtract with y over 5. So we are going to another separate x, y, z, and y, math divide y over 5. Oh, yeah, I accidentally pressed Ctrl G, which is a node group. So y over 5. So if you are like kind of hard to like organize it, you can make them in node group if you want. That is also a method of like organizing it, but I don't have to organize because I know how it goes now. So subtract that, y over 5. So this is Ctrl J, which is y over 5 now. And we're going to subtract that and plus 3 over 4. Oh, look at this. Something is happening now. Value 3 over 4 now. And I'm going to math divide 3 over 4. And math add node like this. Oh yeah, we just made this part. This big one, we just made this big one. Oh yeah, that's going to be really tough, but let's keep going. We can do it. All right. Oh, this one looks very familiar. This is the inverse cosine. We have inverse cosine in math node, so I think we are okay with it. Yeah, we have arc cosine here. It's going to be easy. First thing first, we are going to make this parameter first, and arc cosine, and you know, subtract with these rest of them. It's going to be easy, and we are going to multiply these one and these one here. So value 1, value 5. Okay, separate x, y, z. And this is x, so math divide x over 5. Okay, x over 5, and this is absolute, which is absolute. So x over 5 absolute here, and subtract with 1. So we are going to make another math node. Subtract that. Once we subtract that, this thing is going to be inverse cosine. So let's see how it goes. I'm very curious how it goes now. So math node, set it to inverse cosine. Oh, we got this. Oh yeah, wait, is it correct? Oh yeah, this is correct. No, never mind. It's arc cosine, not inverse cosine. Sorry. Oh, okay. Oh, we don't say an arc cosine. We say inverse cosine. No. Wait, what's going on? Okay, we say arc cosine. Okay. So this one is called arc cosine here, which is to calculate theta, or like, you know, the length of, you know, trigonometry. It's very basic trigonometry. So okay, so once we are done this part, we are going to subtract with the y over 5. Subtract with separate x, y, z node. Control H. Math y over 5. So math divide y over, oh, not what value register. Set to 5 and connect to this second circuit of divide. And this is y over 5. Control J to make a frame to organize it. Y over 5, and we are going to subtract this with the y over 5 here, and we got this interesting looking one. Okay, 3 math divide, we are making this one now, math divide 3 over 4. Oh yeah, we made it. Yeah, pretty cool. And math add node, connect this, and this one is pi, right? Which is irrational number, which is the most important, most famous math constant, right? It's really easy to create. Just basically just very simple. Just type pi in the empty circuit here, and Blender automatically detect pi here. Not only pi, but also it works like Euler's number. You know, Euler's number also works. This is Blender tips. or you can just, like, if you're too lazy, like square root of 3 or something, then you can just type square root and parameter 3, and it Blender automatically calculate it for you. So this is a very useful. It works with anything, like for example principal BSDF, and when you want to, you can just type pi here and Blender automatically detect pi here. And also this render view here, just you can just type pi here and Blender automatically detect pi here. It is like an integer, so pi becomes 3. Anyway, so this is kind of Blender tip, so I hope it was helpful to you. So value, make this name, this node name to value to pi, so that we can like know how it goes. We can also change the color of this node if you want, like a greenish. Yeah, pretty cool. And we are going to subtract with pi. Okay, and we are going to multiply them, these two each other. So multiply. I hope it works. Oh, we got this completely black result for some reason. I don't know how it goes. Vector math node, set it to scale. Oh, it seems like working. Yeah. Look at that. Look at that. It seems like working. Oh, 20. And we're going to make this thing like greater than, to make it like a 0. And oh, we got this hot thing here. It's slightly different. I don't know what it is. Because I think it is because of arc cosine node, because in Blender, like texture coordinate separate, actually math compare y x, we got this y equal x graph here. Like let's say this one, this is x here, right? This is y, and y equal x graph. This is how it looks like. Exactly y equal x, and this is thickness of graph, epsilon. So this is how it looks like. Or you can just change the graph like how we want. Like for example, math. Yeah, this is math y equal x square graph, a very famous one. Or we can also change it to like something else, like a sine. We can also make sine wave with it, like a x, and directly connect to sine here, and we'll get this weird, like a non-linear graph here. Vector math node, set it to scale to see how it goes, and we'll get this sine wave here. Beautiful. Yeah. So anyway, let's keep going. So we just made this thing here, and for some reason we got this weird looking, some, I don't know what it is, but yeah, it's okay. We actually made it. I'm so happy. We're going to make that in frame, which is fourth hot. Okay, let's change the color of frame, like a purple. Beautiful. Oh yeah, this is one of my favorite one. Here are the most hottest part of thing here. So we don't know how to calculate radius here. So for people who wondering how to calculate radius, let me tell you a little bit. This is just very basic math, just a little bit of trigonometry. So we have one unit circle here, and here's the center, and we have a radius here. There are a lot of countless radius here, and we just say this is a radius. Okay, and this is x, and this is y. Okay, then this is x and this is y. Okay, to calculate our radius, what can we do? Just you need to like remind yourself like what you have learned at school. So trigonometry is basically, we learned that a squared plus b squared equals c squared, right? Because these here, let's imagine we have scale here. Then let's just say okay, we can draw it again. So we have x here, then let's imagine there is a big square here. Wow, we have big square, and this one, what is the area? Oh yeah, area of this square. Yes, x times x, which is x square, right? Then what about y? Yeah, we just say y square. Then x square plus y square is z square. So this is how trigonometry works. The like and it's kind of tricky to explain in English. So I would just skip it here. You definitely know. You can just Google it, and there are tons of resources on the internet like about how trigonometry works. So we are going to apply this logic into this thing here. So x squared plus y squared and square root is r. So to calculate r, we can use this equation directly in math node. That's very simple, right? So we're going to make texture coordinate separate xyz node, and as I said, radius is r equal x squared plus y squared square root. So we're going to make this in math node. Math, set it to power, and set the exponent to 2. And make another one. And we're done. We're going to math add node and add that, and we are going to square root that, which will make this circle thing here. Like, because we have like countless radius in our circle, then in the end the radius is just circle. Very simple, right? So we just made it. We just made this a radius now. And to make it more clear, we can use a less than. We'll see this circle here. Yeah, pretty cool. But we have a more simpler way to make a circle. The way is just use a vector math node. There's just one node allow you to make that thing. So I'll just give you a comparison. So vector math node, set it to length. Oh shit. Connect to directly object to the vector here, and this is exactly same as this one. So let me show you. This one. There's no differences, right? So I highly recommend you use vector math node length instead of this big. Yeah, or you can just make this in a like group, like using with a pretty cool like Control G, and you just made a node group. Connect this to the group output here, and you just made a radius here, r. You can name this r, which is a radius, and it works exactly the same as the exactly the same as the length. But I'm simple person, so I'm going to use a length node instead. So this is r, and we just made r, so we are going to make a frame and name this r. Okay, cool. Next thing is theta. Like, we don't know how to make theta in math node. It's pretty simple. Like theta is basically here's the angle of the diameter diagram. So to make theta, wait for a second. To make theta, we need to use separate xyz node, and just one math node allow you to calculate theta. So that we are going to use arctan 2. So arctan 2, this y is going to be on the first socket, x is going to be second socket, and we're done. We just made theta here. Very simple, right? Then we can keep going now. So theta, sine theta, then we can just use sine node here and connect this thing on here. Then we just made it this interesting looking here. So basically arctan 2 is minus pi to pi, which is minus 180 degrees to 180 degrees. So to check this, we can just not save, sorry, Shift D and math and greater than node, and let's see how it goes. Let's type pi here. That will completely black because pi is the maximum of this thing here. Then when we lower this like a pi, half of pi, which is 90 degrees, then it will show up this exactly 90 degrees. So this is how Octane 2 node works in Blender. I mean mathematically, yeah. So we made this sine theta node here. So we are going to make a node group. Not node group, in a frame, sine theta. Okay. We are going to erase them, which is kind of annoying. Okay. Separate XYZ node. And this time it's cosine theta and absolute, and again square root. So it's simple. As I did, Octane 2 node, Y and X. And we made this theta here, math, and set it to cosine. We just made this part here, and we are going to use absolute here. So absolute and square root that. And yeah, we just made this interesting looking thing here, and we are going to multiply these two things each others. So with the math multiply, let's see how it goes. We got this interesting looking thing here. Beautiful. Okay, so once we done making this, we are going to do this part too. So here again, sine theta here, Ctrl Shift D, and math node, and 1.4. So value node, set it to 1.4. And to make them in fraction, as I did, we are going to use math divide. This is going to be first socket, and this is going to be second socket. And we just made this interesting looking thing here. Okay, pretty cool. And we are going to make sine theta again. There are a lot of sine theta today. Sine theta, oops. Ctrl Shift D, sine theta, and multiply with 2. Okay, so we need to multiply with 2 and multiply with 2. Math multiply. We just made it, and we're going to subtract that with this thing. So we are going to subtract this thing here to this thing. We getting close. Okay, math add the value, set it to 2. We are getting close. And to make this r equal, so we are going to use math greater than node, math greater than, r is going to first second of greater than, and second second of this. Rest of them is going to second second. This rest of them is this part here. Let's see. We got this interesting looking thing here. Let's see how it goes. Using vector math node to scale that. Vector math node scale, and we see. Look at that. Look at that. Oh my gosh, beautiful. Vector math node, and we're going to slightly make it move it up here, and scale up. Look at that, exactly same as the reference image. So third one is contains the components. So we are going to use Blender 5.0 version, unfortunately. So lastly, it's time to create a 3D hot in Blender. So in this case, I'm going to use volume instead, because volume doesn't have any like shape here. So it is much more easy to create in Blender Shader Editor, or you can use like a volume cube in geometry node and make this thing. But today I'm going to use a volume in Shader Editor instead. So first thing first, we need principal volume node, and directly connect to the volume of the material output, and we'll get this volume thing, and we can easily modify it using node. So the reason I'm using a cube instead of plane is because we have z components, so we need to, it must be 3D x, y, and z. So that's why I'm using this cube mesh instead of plane. So the density, I'm going to set it to math multiply and set the density to like 30 to make it looking more dense, and we'll see more like a better result. Alright, so this is the default setting, and we are going to create hot step by step. So first of all, we are going to create x square here. So texture, wait, what? Okay, texture coordinate, and separate xyz, Ctrl H to hide the rest of them, and math node, set it to power, set it to square, and we are going to hide them, and this one is going to be F because we are the 5.2 version, which is the experiment version. But so we need to use press F instead of Ctrl J to make a frame. So x square, this one is pretty like complicated, so don't forget to organize it. So value, this value 4 and 9 here, and we are going to make them in fractions. So first of all, we are going to create this part here. So separate xyz node, and we're going to use math node again, and 9 and y, multiply 9 and y, and square that using power node, set it to exponent, and value 4, we're to make them in fraction, we're going to use divide node, and we're simply done. We just made these part here, we just made it, and what we are going to do is make them in a frame. 9y square over 4 basically, and this time z square, next one is z square, separate xyz, math node, set the power to 2, okay, we just made it. So make them in frame, z square, oops, again z square. Okay, we're done. We need to add them, all of these things, and subtract. We're going to move a little bit right on the right. Oh, we get more dense looking. Okay, subtract 1, and with the math power node, set the exponent to 3. We are doing this one, and we make this interesting looking holes here, pretty cool. And this, and next one is going to be this one here, x square and y cubed, separate xyz, x math, set the power exponent to 2, make another one, and z exponent is going to be 3, and multiply that with the node wrangler. You can do this really fast. Node Wrangler is available in Blender add-on. In the preferences, you need to turn on that. Node Wrangler, this one, you need to turn on that. And yeah, we just done this x square z cube. Okay, we just made this thing here, and we need to subtract that with this thing here. Once you do that, we get interesting looking shape here, and we are almost done. We need to do this part here. So value 9, separate XYZ node, connect this directly on the vector of separate XYZ, math, power, set it to 2, and z is going to be exponent is going to be 3, 9, 1, and we're going to multiply these, all of these three things here. Math multiply here, and with value 80 to make them into fraction, math divide. Okay, and we're going to subtract that. This here equal compare, I think. Compare, not compare actually, like greater than, set it to 0. For some reason it's not working properly, so with the vector math node, set it to scale, we can scale up, or we can multiply -1 so that we can like invert that. I'm not sure it's going to be working, but let's try it out. -1. Oh, okay, it seems like working, but I have no idea if this is hot or not. Okay, so I think I fixed it. I just scale up and it fixed it completely. Look at that, we can just scale up more, and I think we made it. We made 3D hot in Blender shader editor using volume principal volume node. Oh, if you want, you can change the color as well, like this color node here, a color panel thing here, and you can change the color as you want, or like texture, coordinate, object here. Oh, look at that, it works, right? And separate XYZ. Oh, we can make this thing looking like this part is a different, this one is like other color, something like that. Like using color ramp, like white, like here, like 0.05 or something, and black. This one is like going to be like something like this, and black is like something like this. Yeah, I think that's it for today's video. I hope this was helpful to you, and I hopefully catch you in the next one. Bye bye.